All right, guys. So let's start with today's lesson. So today's lesson will be lesson number 2 for your Form 4 chemistry. Okay. So before we start, let's do a very quick summary. Let's do a very quick recap. What we covered in the past lesson. Yeah. Okay. So in the last lesson, I mentioned that there are total 8 chapters in your chemistry. So we are starting with chapter 2 because chapter 1 is just introduction to chemistry, which will not be tested in the real examination. Yeah, so we only start with chapter 2. Okay, so chapter 2 is called atomic structure. So what we learned last lesson is quite easy because most of the thing that we learned in the last lesson is something that you learn in your lower secondary. It's something you learn in your Form 1, Form 2, and Form 3. So in the last lesson, we learned about matter. What is matter? Matter is anything that has mass and anything that occupies the space. So it's actually called matter. So all the matter is made by something smaller, we call particle. All the matter is made from particles. So there are total 3 particles out there. We have atom, we have molecule, and we have ion. So make sure everyone here, you all able to differentiate atom, molecule, and ion. So atom is somebody who come alone. So when you are alone, you don't combine with others, you don't have friend, then you are an atom. So molecule is non-metal gang. So non-metal and non-metal join together. Okay. So when you see some non-metal and non-metal join together, they are molecule. They are molecule. All right. So then, okay, we also learned about ion. Ion is somebody that got charged or something made from metal and non-metal. So that is ion. Yeah. All right. So after that, we also learn about the concept of element, compound, as well as mixture. So what is element? Element is anything made from one species. Okay, so when a substance only got one species, then you know it is an element. So compound, you have more than one species. So when you see more than one species joined together, it is a compound. So what is mixture? Mixture means that they just mix together and they can be separated easily. Okay, mixture means that these two fella, they just mixing, they didn't combine and form something new, and they can be separated very easily. That's called mixture. Okay, there's many students, they mess up compound and mixture. Compound, you put something together, they combine, they form something new, it's very hard to be separated. Mixture, you put them together, they didn't combine, they can be separated easily. Yeah. So then we also learn about the comparison of solid, liquid, and gas. Okay. So make sure you know how to draw the solid. Make sure you know how to draw the liquid, and make sure you all know how to draw the gas. Yeah. So I told you all last lesson, they are a bit strict. They are a bit more particular, right? Compared to lower secondary. In Form 1, Form 2, Form 3, they are not so strict on that. So that's why some of the diagram that you draw in Form 1, Form 2, Form 3, like if you draw the way how you draw solid in Form 1, if you draw the way how you draw liquid in Form 1, maybe you won't get any mark at all in your SPM. Yeah. So make sure you know solid, liquid, and gas, and a simple comparison. You must be able to compare their arrangement. You must be able to compare their kinetic energy. You must be able to compare their force of attraction, and you must be able to compare the movement. Okay, so we have 3 types of movement out there. Okay, we have vibration, we have rotation, and we have free moving. Yeah. So make sure you know lah. Okay, solid, what you can do. Liquid, what kind of movement you can do. Gas, what type of movement you can do. Yeah. So in the last lesson, we also learned about state of matter. So state of matter means solid, liquid, and gas. Solid, liquid, and gas. So solid, liquid, and gas, you can change between one and another. So solid to liquid, melting. Liquid change to gas can be boiling, can be evaporation. And I do mention, right, what is the difference between boiling and evaporation? Okay, number one, boiling must happen at boiling point. Boiling only occur at boiling point, not necessarily 100 degrees Celsius, because only water boil at 100, other liquid not necessary. So liquid boil at boiling point. Evaporation happen at any temperature. Another one, boiling happen throughout the whole liquid. Evaporation only take place at the surface. Evaporation only happen at the surface. So gas change to liquid, condensation. So liquid change to solid, freezing. Okay. Then solid change to gas. We called it as sublimation. Then gas convert to solid, deposition. Okay, so make sure you all know all the name of all these processes, and you must know which process absorb energy and which process release energy. So I told you a simple tips, right? In the last lesson, you don't need to memorize. Okay, so if that process you need to break something apart, then you need to absorb the heat. If that process you want to combine or you want them to stick together, then you go to release the heat. Okay? Just use this simple idea, then we will able to know which process should absorb the heat and which process should release the heat. Okay? So what else we learned? We also learned about three lines method, right? So three lines method is a method that can help us to predict the substance is a solid, liquid, or gas at a specific temperature you want. So just draw three lines. The first intersection is melting point. Second intersection is boiling point. Everything here is a solid. Everything here is a liquid. Everything here is a gas. Okay. Then you look at what temperature they wanted lah. Okay. If the temperature is at here, then it's a solid lah. If the temperature at here, then it's a gas lah. If the temperature at here, then it is a liquid. Okay. So make sure you all know lah. Yeah, how to predict whether you have a solid or you have a liquid or you have a gas. Yeah, that is what you need to know. Okay, done. Okay, so I hope everyone okay with this. Okay, so this is what I will do. Normally, when I start with a new lesson, I will spend some time to recap about previous lessons so that you're still able to recall back what you covered in the past lesson. Okay, so let's do one exercise first. Then only we proceed to learn something new today. Yeah. Okay. So this question from Kelantan, okay? So which substance is a liquid at 100 degrees Celsius? So you can use three line method, isn't it? You all can use three line method for it, okay? Example, the first one, melting point, -157, boiling point, -9. So solid, liquid, and gas. So the temperature they wanted is 100. So you ask yourself, where is 100? So 100 is more than -157, more than -9, should be somewhere here. So you should be a gas. So no lah. So substance Q, -13 and 55. So melting point, -13, boiling point 55, solid, liquid, gas. So the temperature they wanted is 100. Where is 100? 100 is more than 55 at here. So you are a gas. Yeah, so not what I want. All right. So the answer is supposed to be C. Why? The melting point is 80. The boiling point is 196. This is a solid. This is a liquid. This is a gas. So the temperature that we wanted is 100. Where is 100? 100 is in between 80 and 196, isn't it? 100 is between 80 and 196, so it's around here. So it is a liquid. Okay. So I hope everyone's still able to recall back whatever things that we learned in the last lesson. Okay. So today we're going to continue and learn something new. So what we learned today will going to be quite interesting. Okay, what we learned today it's actually quite interesting. Because you need to learn something a bit more technical today. Okay, so the lesson for last week is honeymoon. The lesson for last week it's honeymoon. Why? Because most of the concept for the last lesson is something that you all learned before. Yeah, most of the concept in the last lesson, you learn it before in your Form 1, Form 2, Form 3. Okay, but for today, we will learn something totally new, which is not, which you didn't learn before. Yeah, so I want you to pay attention. And if you have any question after my explanation, please don't be shy. Just ask. Feel free to ask me if you have anything that you're not sure after my explanation today. Okay? All right, so let's start. Okay, so let's do it. So today we will start with a new subtopic. Okay, this subtopic is called heating and cooling curve. We will learn something called heating curve and cooling curve. Okay, so first and foremost, you must know heating and cooling curve, why we need to learn that. Okay, heating and cooling curve, they are a special graph. They are a graph. They are a graph that can help us to find melting point, boiling point, freezing point, and condensation point. Yeah, so that's it. So they are a graph that can help you to find what is your melting point, boiling point, freezing point, and condensation point. So this is why we need to learn heating and cooling curve. Okay, before I start, I would like to ask a simple question. Okay, what if this year SPM asks, what is melting point? If SPM this year asks, what is melting point? What would be your answer? Okay, I would like to see your answer in the chat box. Everyone, come on, just try. Just try. Okay, what if SPM asks, what is melting point? What would be your answer? What would be your answer? Come on, I would like to see at least 5 answers in the chat box. Okay, so guys, take your time. I'm looking forward to see your answer in the chat box. Let's try. Okay, what if SPM asks you what is melting point? What would you write? What would you answer if the question asks what is melting point? Okay, so let me show. Okay, I saw a few answers in the chat box. Okay, guys, let me tell you a statistics. Okay, is this an easy question? Yes, it is. This is a very easy question. But the fact, what is the fact? When this question really being tested in SPM, when this question being tested in SPM, okay, less than 20% student can get it correct. Okay, when this question asked in SPM, less than 20% of students can get it correct. But it's a very easy question. It's a very easy question. Okay. So one of the most common mistake by student is this. So many students will write, melting point is a point where solid change to liquid. Wrong. Melting point is not a point. Yeah, melting point is not a point. Some of you will write melting point is a period. Okay, is a period that solid convert to liquid. No, melting point is not a period. Yeah. So some of you write melting point is the material that change from solid to liquid. No, melting point is not a material. So melting point is what? Okay, melting point is a temperature. Okay, like your melting point 40 degrees Celsius, the melting point 80 degrees Celsius, the melting point 45 degrees Celsius is a temperature. And this temperature fixed already, didn't change. Example, this fella melting point is 50 today. Tomorrow, the melting point still 50. It won't become 51. The day after tomorrow, the melting point still 50. It won't become 49. So the temperature fixed already. So melting point is a constant temperature. Constant means fixed already. It's fixed already. Melting point is a constant temperature. Okay. Okay, what happened during the melting? Solid change to liquid. Melting point is a constant temperature when solid change to liquid, and you need to mention at specific pressure. Okay, because melting point is affected by pressure, so you need to mention that. So many students, they didn't write pressure at all in the exam. Okay, so you need to write that. So melting point is a constant temperature where solid change to liquid at a specific temperature or at particular pressure. Okay, that's it. So make sure everyone know this. So you check with your own answer. You all can check with the own answer that you have and you compare with it. Can you see? It's a very easy question, but not many of you can get full mark. Not many of you can get full mark. Okay, like in the chat box so far, I only see one, two, three. I saw three answers that is able to get full mark. Other, no. Okay. So it's a very easy question, but you all have to be super careful. So I hope everyone know what is melting point by now. So if they ask what is boiling point, so boiling point is the same thing. Boiling point is a constant temperature. And what happened? Boiling point, liquid change to gas at specific pressure. Okay. So don't memorize the whole thing without understanding. Many students memorize the whole answer, but they don't understand what is happening. Yeah. So guys, let me know in the chat box, are you okay? What is melting point by now? Are you guys okay? What is the definition? What is the meaning of melting point by now? Okay. So like what I say, guys, it's okay to make mistakes. It doesn't matter. Making mistake is not a big deal. Most importantly, you must know what is going wrong and you can improve from there. Yeah, that's it. Okay. All right. So now heating and cooling curve can help you to find melting point, boiling point, freezing point, and condensation point. Okay, first thing first. The first thing we need to learn today is the shape. What is the shape of heating curve and cooling curve? Okay, heating and cooling curve, they are a graph. The graph is temperature versus time. Heating and cooling curve, they are a graph of temperature versus time. Makes sense. When you heat something, when you're cooling down something, temperature will change. Am I right? When you're heating something, temperature will change. When you're cooling something, temperature will change. So it's a graph of temperature and time. So what is the shape of the heating and cooling curve? Staircase. Okay, staircase. Staircase. So heating curve is the staircase that going up. You see, staircase go up. Staircase go up. Okay. So cooling curve is the staircase that going down. You see, staircase going down, staircase going down. Okay. So heating curve, staircase go up, cooling curve, staircase go down. And again, you not even need to memorize. You can use common sense. When you heat a substance, what happened to temperature? Temperature increase, right? When you heat, it become hot. Temperature go up, right? So heat, so the staircase go up, lor. When you're cooling the substance, when you cool down a substance, temperature go down. So the staircase go down. Okay. So make sure everyone know heating and cooling curve, they are staircase, and the staircase can go up or go down. Yeah. Okay. How many staircase you can have? Maximum two. Maximum two staircases. You won't get three, four, or even five staircases. Impossible. Impossible. You will only get two staircase at most. Okay. How you count the number of staircases? Look at the horizontal line, the flat line. So you see, here got one flat line, one staircase. Here got two flat line, two staircases. Here got one flat line, one staircase. Here got two flat line, two staircases. So maximum only two staircases. You will never get three flat line, three staircases. Impossible. You will never get three staircases. Impossible. Maximum only two staircases for your heating curve and your cooling curve. Okay. So guys, let me know in the chat box, are you okay with the shape of the heating curve and cooling curve and also the number of staircases? Are you guys okay with that? Okay, right. So now the next thing that we want to do is this. So now today we will only focus on heating curve. That's all. So our objective for today is quite easy. We just want to fully understand heating curve. That's all. Because I won't teach you heating curve and cooling curve together in one lesson because it is very confusing. It is very, very confusing if you try to learn heating curve and cooling curve all together in one same lesson. Yeah. So for today, we will just fully focus on heating curve for the next probably 1.5 hours around there. Yeah, we will fully focus on heating curve. So as long as at the end of today's lesson, you understand heating curve inside out, you understand everything for heating curve, that is good enough for today. Yeah, that is good enough for today's lesson. Okay, let's start. So first and foremost, you need to know what is the experiment apparatus, how to conduct the experiment to get heating curve. So today, if I want to get heating curve, I need to do some experiment. How? How to do the experiment? It look like this, okay? So it look like this. So you will first go to take a, a boiling tube. This boiling tube, inside you put the substance that you want to heat. It can be a solid, it can be a liquid, no problem. You can put a solid, you can put a liquid, it doesn't matter. Yeah, all right. Can you put a gas? No lah. If you put a gas, all the gas will run away. True not? Impossible lah. Yeah. So you won't put a gas. So you can put a solid or liquid. Okay. So you need to put a thermometer, of course, because heating and cooling curve, you need to know the temperature, right? Heating curve, temperature keep going up. Cooling curve, temperature keep going down. So of course, you want to get the temperature, you need a thermometer. Yeah. So now you have a beaker. This beaker inside put water, and this water you go and heat it. Okay. Okay. This type of heating, it's called indirect heating. In chemistry, we have direct heating and indirect heating. Okay, what do we mean by direct heating and indirect heating? Let's say this is the test, this is the boiling tube. Today, if you have a Bunsen burner, okay, and this is the fire, if you directly put this further under the fire, this is called direct heating. So indirect heating is this. Indirect heating means you go to put a beaker first, okay? You go to put a beaker, inside put in some water, you heat the water first. When the water is hot, the hot water go and heat your substance. This is called indirect heating. You see that? You didn't heat the substance directly. You heat the water first. Then only the hot water heat the substance. This is called indirect heating. Okay? So when you do indirect heating, you are using water bath. So this water is used for indirect heating. You call water bath. Okay, one of the popular question in SPM, one of the very popular question in SPM is that they love to ask you, what is the usage of water bath? Why we need to use water bath? So water bath is used to ensure uniform heating. You can say uniform heating or you can say even heating. Makes sense. If you do a direct heating, if today you do a direct heating, okay, this whole thing directly put under fire. So if the fire is here, maybe this part temperature higher than this part. Not good. You don't want the temperature to be different. You want the whole thing being heated nicely and equally. But today, if you do indirect heating, no problem. Indirect heating, you see, you heat the water will heat your substance equally from all directions. So the reason why we use water bath, why we want to do indirect heating, we want to ensure that we have uniform heating or even heating. That's it. Okay. So hope everyone understand what this diagram is, the experiment to do the heating curve. Okay. Now, sometimes the water bath need to change with something. Okay. If you don't want to use water, you can use oil bath. So oil bath, the concept is the same. You go to heat the oil. When the oil is hot, then the hot oil eventually heat up your substance. No problem. You can even go for a sand bath. Sand bath, just put sand. You put some sand, you heat the sand. When the sand is hot, the hot sand go and heat your substance. Okay, so it can be water bath, it can be oil bath, it can be sand bath. Huh? In SPM, 99% of the time, you will use water bath. So when should you replace the water bath with oil bath or sand bath? So when we need to when we need to replace the water bath with oil bath or sand bath, when you want to heat the substance to a temperature which is beyond 100. Okay, let's say this fella I want to heat to 500 degrees Celsius. You cannot use water bath. Why? If you want to heat until 500 degrees Celsius, when you reach 100 degrees Celsius, all the water here already boil. And when the water boil, they become gas. When the water become gas, they will run away to surrounding. So sooner or later, what happened? All the water dry already. The water dry up. The water disappear. No more water, all dry already. The water dry already. Do you think when the water dry already, you still can use it to do indirect heating? Cannot, ma. Cannot, ma. The water already dry. How the water can help you to do water bath, to do indirect heating? Cannot. So that's why when you want to heat to a temperature more than 100, you cannot use water bath already because the water will boil, the water will become gas, the water will dry. Understand? So if you want to go for temperature more than 100, you need to replace the water bath with oil bath or sand bath because oil and sand, the boiling point is much higher than 100. Like oil, the boiling point can go to 7 or 800 degrees Celsius. The sand can even tahan up to a few thousand degrees Celsius. Yeah, so that's it. So I hope everyone understand what is the diagram for heating curve and what is the function for water bath and when you should change the water bath with oil bath and sand bath. Let me know in the chat box. Are you okay with the content in this page? Are you guys okay? Do you guys understand all the content that I show you in this page so far? So so you see, it makes sense to you, isn't it? It makes sense to you, right? Or not, okay? So that's why I say everything that I teach you, you must understand the logic behind, not memorizing the answer. Everything you must really understand the idea. Yeah. Uh, so one thing I'm quite happy to see, at least you guys are respond to me. Remember, I told you last week, the simplest thing that you all can do for me is that just respond to me, yes or no, yes or no. At least when you respond to me, I know you are here. Okay, I know you are here. Okay, and I can help you whenever you need to. Because if everyone keep quiet, I have no idea what is happening. Yeah, that's why I really, really hope you all can actively interact with me, actively respond to me. Just a simple yes or no. I will be very, very happy. Yeah. Okay, next one. So we already learned the diagram. We already learned the diagram for heating curve. So the next thing is how to sketch heating curve. Okay, what is the difference between sketch and plot, everyone? What is the difference between sketch and plot? Sketch the graph, plot the graph. What's the difference? Okay, plot need to be very accurate. Plot need to use graph paper and plot need to follow a proper scale. Okay, so you need to be very accurate. Sketch, no lah, sketch, everything just very, we call chin chai lah. Everything very chin chai. So they did, so means like what? Super linear lah. They are not straight. Okay, sketch, they are not very particular. Sketch is not particular. Yeah, as long as the whole thing looks reasonable, it's okay. That is sketching. So now we want to learn how to sketch a heating curve. So heating curve look like this. Heating curve, I want you all to imagine this. So let's say initially you have a substance, you want to heat it. Okay, one more thing to highlight. Sorry, I forgot. One more thing I should highlight. Okay, when we do heating curve, when you use water bath or oil bath or sand bath, you must make sure the water, the oil, the sand must fully cover the subject you want to heat. Example, let's say, put, can I put like this? No. If the water until here, you only heat here. So only this part is heated, this part are not. No, you don't want. You want to heat everything. Remember, when we do heating, we want to make sure we have a balanced heating. We want the heating to be uniform, to be even. Understand? So if you do like this, only here got heated, here don't have. Not good lah. So what you should do is that you must make sure the portion that you want to heat fully immersed in the liquid. So the whole thing must go inside here. Understand? So then only you can heat here, 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 the whole thing. Understand? Huh? All right. So now, when we do heating curve experiment, okay, what we expect to see, okay? So let's say this is the graph. Huh? So the graph is temperature and time, okay? So the unit for temperature must be degrees Celsius law. So the time depends. Sometimes the time is in second, sometimes the time is in minute, depends. The question will tell you, the question will tell you whether they want the time in second or minute. So when we start heating, we are not heating from zero. We are not starting from zero one. So normally when we heat, we start from room temperature. 1 minute revision, everyone. How much is room temperature, everyone? How much is room temperature? We learned last week. How much, everyone? Room temperature, how much? 25. So normally when we start to do heating curve, we are not starting from zero. We start from 25 around here. Yeah, we start from here, around here, 25. So when you start heating, when you heat the substance, you will notice the temperature will go up. Yeah, the temperature will slowly go up. 25, 27, 29, 30, 50. So until you reaching a melting point. So once you reach melting point, the temperature will stop changing. The temperature will stop. Yeah, once you reach melting point, the temperature do not change already. They don't increase, they don't decrease. The temperature will be constant until all the solid here melted, until all the solid fully melted to become liquid. After the solid become liquid, then you continue to heat, the temperature continue to shoot up. The temperature continue to shoot up. Then until you reach boiling point. When you reach boiling point, you will see bubble, 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 because all the liquid now become gases. Okay. So when you do the boiling process, same thing, the temperature will stop changing throughout the entire boiling process. Once the boiling process started, the temperature stop changing. It will just stay at the temperature until all the liquid here become gases. So when all the liquid become gas already, you continue to heat, the temperature continue to go up. That's all. Okay. So this is how you sketch your heating curve. Understand? Make sense, right? Staircase going up, maximum 2 staircases. Okay. So that's it. Okay, so I hope everyone know how to sketch your heating curve. How to sketch your heating curve. Okay, and you must know. Okay, when you do the heating curve, okay, during the change of the state, when you do the change of state means what? You change from solid to liquid, liquid to gas, okay? When you change from one state to another, the mass didn't change. Make sense? Let's say you have 1 kilogram of solid. When you heat it, you get 1 kilogram of liquid. When you have 1 kilogram of liquid, you boil it, you will get 1 kilogram of gas, okay? So the mass will be the same. You cannot say, or I have 1 kilogram of solid. When I heat it, I get 7 kilogram of liquid. Doesn't make sense. I have 2 kilogram of liquid. When I boil, I get uh I get I got 2 kilogram of liquid. When I boil it, I get 1 kilogram of gas. Doesn't make sense. Okay, the mass should be the same from beginning to the end. Number two, temperature didn't change. When you do melting, when you do boiling, when you do condensation, when you do freezing, the temperature will stop changing. The temperature is constant. So make sure everyone know this. So hope everyone know how to sketch your heating curve. Okay. All right. Now, so the next thing we want to learn is how to analyze. How on earth we can analyze, how to do analysis for your heating and cooling curve. Okay, listen carefully. This is super important. When you have 2 staircases, the life is wonderful, the life is beautiful. Why? When you have 2 staircases, it's easy because you know the first staircase is melting. The second staircase is boiling for sure. Okay, by the way, guys, the change of state always happen on the horizontal line. Okay, all the change of state like melting, boiling, freezing, condensation always happen on horizontal line, which is the flat line. So this flat line is where the magic happens: melting, boiling, condensation, and freezing. Understand? So when you have two staircases, it's easy. You know the first staircase is melting, second staircase is boiling. For sure lah, because common sense, melting come first, right? Then only boil. You cannot say, I want to boil the substance first, then only I melt it. Doesn't make sense. Must be melt, then only boil. So that's why whenever you saw two staircases, is super, super easy. First staircase, confirm melting. Second staircase, confirm boiling. Easy. But the problem arises. The problem arises when you only see one staircase. When there is only one staircase, then you have to be careful. Because when you only have one staircase, maybe it's melting, maybe it's boiling. Am I right? Okay. So why it cannot be freezing? Because we are doing heating curve, right? When you heat a substance, you won't do freezing, right? Freezing and condensation only happen when you do cooling. Am I right? When you heat a substance, only melt or boil. That's it. So you see, when you only have one staircase, maybe it is melting, maybe it's boiling. So we are in a trouble now. Because if two staircases, easy. First staircase melting, second staircase boiling. But if you are only given one staircase, you are in deep trouble. So how to know when we only have one staircase whether the process is a melting process or whether the process is a boiling process? Okay, so look at here. So if you only given one staircase, if you are only given one staircase, maybe the staircase representing melting, maybe the staircase present the boiling. So what you should do, you need to read the question carefully in order to check the starting material is a solid or liquid. You must know the starting form is a solid or liquid. Let's say if you only see one staircase, maybe it's melting, maybe it's boiling. And then the question they say, Martin, this is a heating curve for solid X. Then you know already, no? You start with solid, common sense. When you given a solid, you heat the solid, melting lah. Am I right? So if they only give you one staircase, they say, Martin, this is a heating curve for liquid A. So you know already, one staircase might be melting or boiling. One staircase might be melting, might be boiling. They tell me this is a heating curve for liquid A. Common sense. You have a liquid in the first place, you heat the liquid, boiling, like right? You heat the liquid, you will boil it, not melt it. Understand? So make sure everyone know when you have two staircases, life is beautiful because you know one is melting, one is boiling. But you only have one. If you only have one staircase, you have to be careful because the one staircase might be melting or might be boiling. So how to know? Read the question carefully so that you know you're starting with a solid or you're starting with a liquid. Okay, guys, let me know in the chat box. Are you okay what to do when you have one or two staircase? Are you guys okay with that? Do you guys understand what you should do when you have one staircase and what you should do when you have two staircases? Okay, can, very good. So again, guys, anything you're not sure, just ask. Anything that you're not sure, just ask. Don't be shy. Don't be shy. Yeah, please. Don't be shy. Okay, all right. So, okay, done. Okay, now, okay, for the next part, I will spend some time to teach you how to analyze. So now I will spend some time with you all to teach you how to do the analysis, how to analyze the heating curve and cooling curve. All right, so let's do it. Okay, first one, okay. So let us learn how to analyze the heating curve and cooling curve. Okay, put your eyes on here, please. So just imagine we have a heating curve like this, okay? So this is temperature and this is time. Okay, so now we have two staircases, okay? All right. So now let's assume this is A and B, this region called AB, this region called BC, this area called CD, this area called DE, and this area called EF. Okay, so now we want to study, okay, this is the region A to B, B to C, C to D, D to E, and E to F. So now we need to learn how to analyze the state of matter. Okay, again, guys, what do we mean by state of matter? In SPM, when you see the word state, it means solid, liquid, or gas. Okay, when you see the word S-T-A-T-E, state, it means solid, liquid, or gas. Okay, all right, now, how to know whether you have solid, liquid, or gas or not? Okay, so this one, I want everyone to listen carefully. Okay, so when you have two staircases, you know the first staircase is melting, right? The second staircase is boiling. You all should know that. Yeah. Okay. So now I want you to zoom in to here. All right. So this on this horizontal, remember I told you on the horizontal line, they change from one form to another form. They change from solid to liquid, liquid to gas. This is where the magic happens. Okay. So I want you to see here on this line, this is the starting, right? And this is the ending. So this is where the melting started. At here, the melting already start. So then the melting continue until here. This is where the melting ended. Okay? So melting happened on this line. Melting started at here. Melting ended at here. Okay? So same thing goes to here. This entire line is where the boiling happened. This is the line where the boiling take place. So this point is the first point on the line. This is the point when you start to boil, when you get the first bubble, yeah, when the boiling first started. This is the point when the boiling ended, when all the liquid, the last drop of liquid become gas. No more already liquid. So the boiling totally ended. Okay, so make sure you know where is melting, where is boiling, when they started, when they ended. Okay, now common sense. So A to B. So from A to B, at here, is melting happening? No, melting happening at here. So A to B is before, right? Before melting. So when you have a substance, when the substance not melted yet, when the melting not starting yet, so everything should be a solid proton. Make sense, ma? Melting happen at here. You are now at here. No, not yet melting, right? Okay, now this one you have to be super duper triple careful. Here. When you are on BC, melting, it's ongoing, right? The melting is ongoing. The melting is happening. So when melting is happening, you will always get two states. When melting is happening, you always get two states. What is it? You will get solid and liquid. Why? The melting is happening. So some solid not melted yet. So you have solid lah. Some solid already melt, it become liquid. So you will have solid and liquid. Understand? You will have solid and liquid. So if they ask, at this point, what you have? Solid and liquid. Okay? Because melting just started. At this point, what you have? Solid and liquid. Because melting is ongoing. And at this point, what happened? Solid plus liquid. Melting is still ongoing. At this point, what we have? Solid and liquid. The melting still ongoing. At this point, the melting ended. When melting end already, no more solid. Everything become liquid. See that? So when you are on this horizontal line, at here, solid, liquid, 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 solid, liquid. Here, everything liquid. Because at here, melting ended. Yeah? Done. All right? So now you are here. So here is what? This is melting. This is after melting, right? So after melting, all the solid melted. After melting, liquid, everything already become liquid. Okay? Because at here, the boiling not started yet, right? At here, melting completed, but not yet boiling. Boiling is here, yeah? Okay, now we go to horizontal line again. So now we are at the horizontal line. The boiling is happening. So when the boiling started, ongoing, 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 what we have. So when boiling is happening, you will always get two things again, liquid and gas. Why liquid and gas? Some liquid not boiled yet, some liquid already boiled become gas. So when you are on the horizontal line, this is the starting for boiling. So here, liquid plus gas, 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 until here. This is when the boiling ended. When you are here, the boiling end. When you end the boiling, everything here is gas. Okay, done. Next one, here. So now you are at here, E and F. So E and F, this is boiling, this is after boiling. So the boiling is done. The boiling is completed, already done. So when already done, everything become yes. So that's why you all can see a simple thing. When you are on the slanted line, like this, slanted, the garis sengit, yeah? When you're on the slanted line, like this, you only see one state. When you are on the horizontal line is where the magic happens, where they change the state. When you are on horizontal line, when melting is ongoing, when boiling is ongoing, you will see two states. Okay, so very easy one. When you are on slanted line, one state. When you are on horizontal line, two states. That's all. So guys, ladies and gentlemen, let me know in the chat box, are you okay how I do the analysis? Are you guys okay how I do the analysis? Okay, so when you have this logic in your mind, everything will be very reasonable. Everything will be easy and very reasonable if you get the idea. Okay, now let's do some simple exercises. Yeah, let's do some exercise together. The exercise can help us better in this way. All right, so everyone, let's follow this. Okay, this is a simple self-test. So simple self-test. Self-test is to test you, test your understanding. All right. So this is a heating curve. How I know it? I saw a staircase. I saw a staircase. I know this is heating curve. How many staircase we have? Only one staircase. So when you only have one staircase, you all have to be careful lah, because I told you one staircase might be melting or one staircase might be boiling. So guys, make a wild guess. This staircase is melting or boiling? M or B? Make a wild guess. You think this staircase is melting or this staircase is boiling? Make a wild guess. Make a wild guess. You think this one staircase actually is melting or boiling? Boiling, why? I told you all just now, right? When you have one staircase, you need to read the question carefully. For what? You need to read the question carefully to figure out you are starting with a solid or liquid. Do they give us any tips? Yes. Diagram above show the heating curve of teh tarik. That's the tips. So they tell you you have teh tarik. Common sense, teh tarik is liquid lah. Do not. Teh tarik is a liquid. So you have a teh tarik, you have a liquid in the first place. Common sense. When you heat a liquid, boiling. Understand? When you heat the liquid, boiling lah. Common sense, all right? No need to memorize, no need to memorize, isn't it? Okay, now. So now the question is, we want to predict what is the state of matter at T1, T2, T3, and T4. What is the state of matter at T1, T2, T3, and T4? Okay. So guys, let's try. Okay, this is boiling. So T1 is on the slanted line. Boil already? No, not yet boil. So before the boiling even occur, so T1 should be what? Liquid. Am I right? T2. T2 is on the horizontal line. The boiling just started. When boiling start, liquid and gas. Yeah. T3 is on the horizontal line. The boiling is ongoing. The boiling is happening. So when the boiling is in process, is ongoing. So liquid plus gas. Am I right? T4 is here, the last point on the horizontal line. Well, so when you're on the last point horizontal line is what? This is where the boiling started. This is where the boiling ended. So when the boiling end already, when boiling finish, you shouldn't get any liquid because all the liquid already boil, all the liquid already become gas. T5 is on the slanted line. We know slanted line only have one state. So this is boiling. So this is after the boiling. If after boiling, T5, everything is gas. So I hope everyone know what is going on, how I figured out T1, T2, T3, T4, T5, what is the state that I have. So state means solid, liquid, or gas. That's all. Okay? So I really, really hope you all understand how I tackle this question. Let me know in the chat box. Are you okay? If you're okay, type TT. TT stands for teh tarik. Are you guys okay with this question? If you're okay, type TT, yeah? Teh tarik. So not very hard. Okay, so if you understand the entire logic, it's not so complicated actually. It is very doable. It is very, very doable. So you can see, I focus a lot on your understanding. Yeah, I really, really focus a lot on your understanding. I don't want you to memorize, memorize, memorize. No point. No point doing that. Yeah. When you really understand something, you will be able to do it for a very, very long time. Seriously, when you're able to understand something, you can do it for a very, very long time. Okay? Because most of the students, they only go by memorizing. To be honest, okay? To be honest, most of the students only memorize one. Okay? That's why I always challenge my student in this way. Okay, guys, you see, let me tell you something here. Okay. Let's say let's say you love to play football. Okay, you love to play football or whatever sport it is. Okay, let's say you didn't play football for 10 years. Okay, guys, after 10 years, you touch football again. Do you think after 10 years, you will forget how to play football? Yes or no? After 10 years, do you forget how to play football if you didn't touch your football for 10 years? Yes or no? After 10 years, do you think you will forget how to play football? Yes or no? Okay, the answer by right should be no. Very unlikely one. Very unlikely. If you really love a sport, if you didn't play for 10 years, maybe you are rusty. Maybe you say, I'm not as good. I cannot play so well. But you won't forget how to play football, my friend. Example, you didn't play badminton for 10 years. Maybe you forget some rules, but you won't forget how to play badminton, right? You won't forget how to hit the shuttlecock, all these things, right? True or not? Okay, why? When you really understand or you love something, you won't forget easily one. But it's different from your study, okay? Yesterday is your sejarah paper. After 2 weeks, you forgot everything, okay? Not two weeks, 2 days, okay? I really got student like this, like today is sejarah SPM paper. Wow, legend. They know everything. But 2 days after the sejarah paper, they forgot everything. It's like they never learned the subject before. It's like they never learned the subject before. Totally blank one. Okay. So that's why they are memorizing the whole thing. They don't understand it. That's why I always put a challenge to a student. Okay. I always challenge my Form 5 student. I say this. I always challenge my Form 5 student. I say, okay, this is me. I didn't touch physics. I teach chemistry. I didn't touch physics for 18 years. Okay? I didn't touch, I didn't teach, I didn't learn physics for 18 years. Okay? This is a SPM student, okay, having SPM this year. Okay, I always challenge my student. I say, okay, now let's say we go into an exam. Let's say after 3 days, we go for SPM. We go for SPM exam. You can do whatever revision you want. You read. You do whatever revision, you do whatever exercise you want in 3 days. For me, I didn't touch physics for 18 years. Not chemistry, physics. I didn't touch physics for 18 years. In these 3 days, I don't need to read any book. I don't need to read any book. I don't need to do any exercises at all. After 3 days, together we go into exam. Okay? My result will better than more than 90% of students. Trust me on that. My result is better than 90% of students who take SPM this year and who read all the things for 3 days. I didn't read anything for 18 years. I'm still better. Okay? Why? Okay? For your information, physics is one of my favorite subject back then. Okay? Physics is one of my favorite subject back then when I was taking my SPM. And I really, really, really understand physics. I really understand physics inside out. So when I understand something, I won't forget easily. True, okay? Like even today, you ask me anything, force and motion, energy, light, wave, electromagnetic, nuclear power, I'm okay. I still can do it. Bear in mind, everyone, I didn't touch physics for 18 years. But because I really, really understand the concept, so even I don't do any revision, I still can do it. Seriously. Seriously. Okay? So the reason I tell you this, just to let you know the importance of understand. Because when you understand something, you won't forget so easily. Even if you forget, you can recall back your knowledge very fast one. You can recall back the knowledge very fast one. Trust me on that. Yeah. That's why I keep emphasizing on the importance of understanding. Don't keep on reading without understand. No point. Okay? Right? That's why you see a lot of SPM students, they get straight A. Yeah, they get straight A, but they don't understand. Yeah? They don't understand one. Yeah? Because after a few days, they forgot everything already. But they got straight A. Yeah? So they are good in exam, but they don't understand. Yeah? So I don't know, maybe that is something you want, but I not really like it. I really hope that when you learn something, you really, really learn something. You really understand it. Okay. That is my hope. Yeah. Okay, anyway, let's go on. Let's do some exercise together. Then only we learn how to analyze, how to explain. Okay, now everyone let's look at here. This question is from Terengganu. This question coming out in Terengganu is a trial exam paper in the year of 2023. Terengganu. Okay, so diagram 1 show a curve for the change of state of matter for solid Z. Okay, so what is this? You all can see this is a staircase. So this is a staircase. So this one obviously is a heating curve. How I know this is heating curve? Staircase going up. Remember, staircase go up, heating curve, staircase going down, cooling curve. So you only have one staircase, maybe it's melting, maybe it's boiling. So how to know it is melting or boiling? Read the question carefully. Read the question carefully. So they say this is a heating curve for solid Z. So you're starting with solid. So solid, when you heat it, melt or not. So it's a melting. So you know really this is melting. Yeah, this is melting. All right. So what is the point X and what is the physical state? So point X is the temperature. This is the temperature when the melting occur. So this point X should be your melting point or not. This is the temperature where melting started. So this is your melting point. So X should be melting point. Okay. So the process is melting. So what is the physical state from R to S? R to S is on the horizontal line. When you are on the horizontal line, the change of state is ongoing. So when the change of state is ongoing, you always get two states, or not? So solid and liquid. So the answer is donkey. Yeah? So I don't think it's very hard, right? I don't think it's very hard. This question is very doable if you really understand the logic. Yeah, if you really understand the logic, this question is quite doable. Yeah. So let's try another few more question. Let's try another few more question here. Okay, here. This question appeared in Johor. This question appeared in Johor in the year of 2022. They asked what process actually happened between 0 to 10. 10 to 30. 10 to 30 is here. So this is quite easy. Okay. This is a heating curve, one staircase, maybe is melting, maybe is boiling. So they say this is heating curve for solid. So when you heat a solid, melting. So this process is a melting process. Yeah. So I think that's quite easy though, and makes sense because melting is ongoing. So you have solid and liquid mixing together. Yeah, because if boiling, you should get liquid and gas. Huh? All right. Next one. Yeah. This question came out in MRSM. This is another good quality trial exam paper. Okay, so which statement can be deduced from the diagram? So what you have? So same thing, this is a heating curve. So this one only have one staircase. So one staircase maybe is melting, maybe is boiling. So we have to read the question carefully. So they say this is heating curve for solid acetic acid. So you're given a solid. So when you given a solid, you heat the solid, melting. Yeah. So you know this is melting. So they say which statement is correct? No heat is absorbed in the first 2 minutes. No, heating curve will absorb the heat from beginning to end. When you do heating curve, you heat the substance. So when you heat the substance, all the heat will be absorbed. Yeah, they will absorb the heat from beginning to the end. So they say no heat absorbed. That's wrong. B, acetic acid need 8 minutes to melt completely. So many students get cheated. 8 minutes, oh, looks make sense. No. How to know the time needed for melting? So melting started at here, right? Melting ended at here. You started the melting at 2 minutes. The melting ended at 6 minutes. So how long is the duration? 6 minus 2. So you only need 4 minutes for the melting to happen, not 8 minutes. Yeah, we only need 4 minutes for the melting. So it's wrong. C, acetic acid undergo physical changes between the second minute to the 6 minute. Yeah, second minute to 6 minute melting. So melting is a change, is a physical change. Correct what? Melting change physically from solid to liquid. It is a physical change. So answer C makes sense. Okay, donkey. The force of attraction becomes stronger after 6 minutes. Okay, so after 6 minutes, so we know this is melting. Before melting, everything is solid. After melting, everything is liquid. So we know solid, everything sticking together. So the force is very strong. So when you do the melting, you become liquid. Liquid, something sticking, something not sticking. So the force is moderate. The force is not so strong already. So the force go from strong to moderate, should become weaker, right? Not stronger. They say the force is getting stronger. Doesn't make sense. So the answer is C. So let me know in the chat box, are you okay how I solve this question and how I arrive at the answer C? So I want you all trying to pick up my mind. I want you to try to learn the way how we tackle the question, how to think, what is the logic, what is the strategy that we can use to handle all these questions. This is something that I hope you can learn from me. Yeah. So now we go for another few more questions. All right, here we go. Okay, this is the one. Okay, this question came out in Kedah. So the next question here, this is a question appeared in Kedah. Okay, back in the year of 2022. Back in year 2022, this question appeared in Kedah. Okay, so they say diagram shows the heating curve for a solid Q when you heat from room temperature all the way until 258 lah. So can we analyze this? Yep. So this is a heating curve. This one got two staircases. So you know already, two staircase. The first one is melting. The second one is boiling. Am I right? So you have melting and boiling lah. Okay. So make sure you know two staircases. The first one is melting. The second one is boiling. So they ask which one is correct. Huh? So the first one they say Q exists as liquid at 258. So 258, where are you? 258 is here. So 258 is on the horizontal line, which is when boiling is ongoing. So when boiling is happening, when boiling is ongoing, what we have? Liquid and gas. So not when boiling is ongoing. When you are on horizontal line, you always have two states. So should be liquid and gas. Okay. But they say only liquid. So which is wrong? B. Q exists as solid at T1. So where is T1? So T1 is here. So T1 is on the horizontal line. So T1 is where the melting started. When you start melting, you already have solid and liquid. So not when the melting started, you should already have solid mixing with liquid. But they say only solid. No, should be solid and liquid. C. Q exists as liquid at T2. T2. T2, you have liquid. T2, where are you? T2 is here. Is the last point of melting. The melting ended. So common sense. When melting ended, all the solid melted, all the solid become liquid. So it's only liquid. So makes sense. So the answer C looks good for me. Answer donkey. The boiling point of Q is 105. The boiling point of Q is 105. So boiling happened at here. What is the temperature for boiling? 258, not 105. 105 it's at here. It's melting point. So 105 should be melting point, not boiling point. So the best answer is C. Okay, that's it. Okay, so I really hope you all understand the logic, how to tackle this question. Right, let's go for one last objective question. Then we move on to subjective question. Okay, one last objective question is here. So this is a good K-but, K-but, or we call critical thinking question. So don't be phobia, don't be scared of K-but question. Many students, when they first heard about K-but, so they will be very scared of it already. No, not really. If you really understand the logic, you don't need to be so fear of the K-but question actually. Yeah, all right. So now let's have a look. Okay, how are we going to tackle this question? So again, everyone, as you all can see, this is a heating curve. How I know? I saw staircase going up, right? When you see staircase going up, it is your heating curve lah. Yeah, we saw a heating curve here, all right? So now, how are we going to do this question? How are we going to do this question? Okay, so let's have a look. Okay, so first thing first. So we know there are two staircase here, right? We have two staircase here. So the first staircase here should be melting. The second staircase here absolutely would be boiling, right? Or not? I know that. Okay. So now what is the next thing that we can move? We can proceed. Okay, they say, which of the following phases show the strongest force of attraction between naphthalene particle? Okay, so guys, we learned before the force of attraction. So strongest force of attraction. Guys, anyone can tell me what is the hidden information they want to ask? When they say strongest force of attraction, make a wild guess what they're looking for. When they say strongest force of attraction, what they actually looking for? Solid, very good, solid. Because we know solid, everything sticking together, the force is very strong. Liquid, something sticking, something not sticking. So the force is moderate. Gas only stick a bit, the force is weak. So in this case, they say who has the strongest force. So even though they didn't tell me, I know that they are looking for solid. So at where we have our solid. So we know This is melting. So before melting, everything solid, right? During melting, solid and liquid. After melting, liquid. During the boiling, liquid and gas. After boiling, gas, isn't it? So where we want? Solid. Solid, they are sticking together, they have a strong force. Solid. Where is solid? Here. PQ. So answer P to Q. So is this question hard? Not really. But this question not so straightforward, right? So not, they purposely put a trap. They purposely set a trap. They don't tell you they want solid. They give you a hint. Strongest force of attraction. So guys, do you mind to reply to me and let me know in the chat box, are you okay how I solve this K-but question? Are you guys okay how I solve this critical thinking question? Are you guys okay with that? So this question is interesting. Yeah, this question for me, I think is quite interesting. Yeah. So if you have anything you're not sure, feel free to ask. If you have anything that you're not sure, please feel free to ask. Yeah, you can ask. Yeah, if you really want to figure out more and more information. Yeah. All right. I hope all is well. I hope everyone is okay with this. All right. So done. Okay, so we're all done with objective question. Okay, let's do one quick subjective question together. Then only we move on and learn the last thing for this entire lesson. Okay. Right. So this question appeared in Selangor. This question is a trial exam paper in Selangor in the year of 2023 lah. Okay, this is a trial exam paper in Selangor in the year of 2023. Yeah. So let's have a look. What is it and how are we going to solve it? How are we going to solve this question? So the first one, what is the meaning for melting point? So I guess you all should know. Yeah, I guess you all should know what is melting point. Okay. So melting point is a constant temperature. Okay. So what happened at this temperature? What happened for the melting point? Melting point is a constant temperature at which, okay, the solid change to liquid. Okay. And don't forget, you need to mention what? The pressure, okay, at a specific or at a particular pressure. Don't forget about pressure. If you forget to write the pressure, examiner will forget to give you the mark. So you get 0. Yeah, you get 0. So don't be forgetful. Don't be forgetful. You forget, they forget. You forget to write, they forget to give you the mark. Okay. So please be very, very careful. Yeah, please be very, very careful on this lah. Okay, it's not hard actually. Yeah, it's not really hard. Okay, so next one. Okay, what is the type of particle found in naphthalene? So when you see the word particle, means what? Atom, molecule, or ion. So naphthalene is made from carbon and hydrogen. Carbon and hydrogen, the name don't have ion, don't have ion, so they are non-metal. So non-metal carbon, non-metal hydrogen, they join together, you get molecule. Yeah. What is the physical state of naphthalene at room temperature? So naphthalene, what is the physical state? So how you know what is the physical state? There are two ways to do this question. There are two ways to do this question. The first one, if you look at this picture, do you see dotted line? If you don't see dotted line, it is a solid. You see, when you see dotted line, is a liquid. When you don't see dotted line, is a solid. Second thing, they tell you they want you to find melting point for naphthalene. So they want to melt the naphthalene. So initially, before you do the melting, so at the room temperature, what is the naphthalene? Solid, no? Am I right? You have a solid, you want to melt it, right? So from here, I know already, naphthalene is a solid at room temperature. What is the purpose of using water bath? Why we use water bath? So we know water bath is used for indirect heating. Why we want to do indirect heating? To ensure we have a even heating. If you don't want to write the word even heating, you can write to ensure that we have uniform heating. Yeah, you want the heating to be balanced, to be nice. Yeah, that's all right. So next one. Okay, this one we haven't learned yet. Okay, we come back in a short while. Okay, so that's it. Okay, so I hope everyone is okay. I hope everyone is okay up to this moment. It's not very, very hard. Yeah, so I hope so far so good. I hope up to this moment so far so good. Okay, now let's move on to learn the last part for heating curve. Heating curve almost done. 90% done. So now we left the last 10%. Let's go and do it. Okay, so now the last part that we need to learn for heating curve is we must be able to explain. We must be able to explain what happened at here, 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 and here. What happened? Yeah. What happened in process AB? What really happened from the process BC, CD, DE, and EF? So this is what something we will learn, and this is the last thing that we need to know for today's lesson. Yeah. So let's do this. Then after that, we will do a few more exercises. Then we are all done for today's lesson. Yeah? All right. So come on. Okay, let's pay attention. So last 30 minutes to go for today's lesson. Let's do it. Okay. So let's look at here. What happened from A to B? So here, I don't want you to memorize. I will draw some picture. I want you all to imagine. I need your imagination. I need you to imagine what is going on. So you see here, so A to B is what? This is melting. So this is before the melting occurs. So you can see, so this is your test tube. When you heat the substance, at here, the melting not happening yet. The melting is not happening yet. Okay. And then you can see the temperature actually is going up, right? Makes sense. When you heat the substance, temperature will go up 25, 35, 45, 50, and so on. Temperature go up. So why? Why at here when you heat the substance, the temperature is going up. Why? Okay, so I want imagination. So first of all, we have solid, right? So I want all of you to know. So all the particle, they have energy. All particle, they have their own energy. The energy is called kinetic energy. Yeah. So all the particle, they have energy. For example, let's say this particle got 10 joule, this one got 11 joule, this one got 11 joule, this one got 12, this one got 10, this one got 10, this one got 11, this one got 12, this one got 12, for example. This number, no need to memorize. I just want you to know all particle, they have energy, and the energy not necessarily the same. Yeah, the energy not necessarily the same. Some particle got more energy than others. Yeah. So now, when we do heating, so you see, when we do heating curve, when you do heating, all the heat will go inside the particle, right? All the heat, they will be absorbed by the particle. So when you do heating, all the heat will go inside the particle. Am I right? Okay. So when all the heat go inside the particle should have more energy, isn't it? Like, okay, initially you have 10 joule, now maybe you become 15. Initially you have 11, now maybe you are 16. Initially you have 11, now maybe you are 16. Understand? Something like that. Yeah. All right. So now all the particle here, they will have more and more energy, right? That's it. And I want everyone to know this, okay? Kinetic energy always related to temperature. I want you to know kinetic energy and temperature, they are best brother. They are best brother. They are twins. Whatever happened to kinetic energy, same thing will happen to the temperature. So when kinetic energy increases, temperature will follow to increase. When kinetic energy decrease, temperature follow and decrease. When kinetic energy don't change, temperature follow, no change. So I want everyone to know kinetic energy and temperature, they are like twins. Whatever happened to kinetic energy, same thing happened to temperature. So now what happened here? So when you heat the substance, all these particles, they absorb the heat, right? The particle absorb the heat go inside the particle. So when the heat go inside the particle, now your particle got more and more energy. When the particle got more energy, so what happened to temperature? Increase or not? When kinetic energy increased, temperature increased. So that is the reason why at here temperature go up. So if they ask us to explain why at here temperature go up, this is your answer. The heat is absorbed by the solid particle. So when the solid absorb the heat, the solid got more and more energy, kinetic energy go up. So when the solid got more energy, temperature will follow, because temperature and kinetic energy, they are twins. They do the same thing. So if you're okay with what happened here, can you type AB in the chat box? If you understand how to explain what is happening in the AB, can you please type AB in the chat box for me? So can you imagine, everyone? Imagine what is going on. Okay, when you hit the substance, the heat go inside the particle got more and more energy. When the particle got more and more energy, temperature will increase as well. Yeah. So this is what happened. Yeah, this is what happened from the region of A to B. Yeah, this is what happened in the A and B here. Okay. All right. Done. Okay. Okay, so now let's look at here. Now, this is the popular question. They love to ask this question. They always love to ask why temperature didn't change. Why temperature is constant when you do melting, when you do boiling. And this is a super popular question in SPM. This is a very, very common, very, very popular question in SPM. And they love to ask why. Why temperature is constant? Why temperature no change during the melting, during the boiling? Why? So this one again, I want you to imagine. I want you to imagine what is happening. All right, so melting. So why melting the temperature didn't change? Okay, melting. So melting want to change the solid like this all the way to liquid like this. Yeah. So why the temperature didn't change when you do the melting process? Why? Okay, first of all, we know all the particle got energy, right? Okay, let's say this is the energy lah. Okay, okay, all the particle got energy. Okay, now why the temperature didn't change during the melting? Like this one, when you do the heating. Okay, why the temperature didn't change when you do the melting process? Okay, because when you heat the substance, the heat will go in, right? Okay, previously we know the heat go inside the particle, so not previously, the heat go inside the particle got more energy, right? But now, no. Now what happened? Okay, we know if you want to change solid to liquid, what you need to do, all the solid, they are sticking together with force of attraction. So not all the solid, they are sticking together with the force of attraction. So you can imagine like all the solid, they are like holding their hand together. So now you want to break them apart. You need to break them apart, then only the solid can become liquid. So if you want to break them apart, you need heat. So you need to use the heat to cut them apart. So that's why in this case, what happened? All the heat that coming in is not going into the particle. No, all the heat coming in is used to cut, 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 cut. It's used to cut the solid. Why you want to cut the solid? If you didn't cut the solid, you won't become liquid, right or not? Okay, you are not allowed to use the word cut. So what is the proper word you should write? Okay, from B to C, melting take place. Okay, so look at here. All the heat absorbed, all the heat that you absorb, all the heat that you coming in, you use the heat to overcome the force of attraction between solid particle, because all the solid, they have the force of attraction, right? All the solid, they have some forces that stick them together. So now you want to cut the forces. And how to cut the force? Use the heat. So all the heat come in, use to cut the force. But you don't use the word cut lah. You use the word overcome. Overcome the force of attraction. Yeah. So when you use all the heat already, when all the heat you use to cut something, do you think you still have any heat can go inside? No, right? All the heat already used here to do cutting. So no more heat can go in the particle. So when no more heat go into the particle, do you think this particle, the energy will change? No. The particle, the energy will be exactly the same. They are not increasing or decreasing through not because the heat didn't enter. The heat don't go inside the particle. The heat go and cut the solid. You use the heat already. You use all the heat, nothing left. No more heat can go inside. So when no more heat can go inside, all the particle, the kinetic energy no change. When the kinetic energy no change, temperature for sure no change because kinetic energy and temperature, they are best brother. They are best brother. Whatever happened to the kinetic energy, the same thing will happen to temperature. So I hope everyone can imagine now why when melting is happening, when boiling is happening, temperature didn't change. Same thing, boiling also same thing. You see, when you do boiling, how come the temperature will become constant one? Why? Why boiling temperature didn't change? Same thing, boiling, want to change your liquid to gas. So to change liquid to gas, you need to cut them apart, right? How to cut? The heat. All the heat used to cut. Do you think the heat can go inside the particle? No. All the heat used to cut them apart. So when you use all the heat already, no more heat left, no more heat can go into the particle. So do the particle energy got changed or not? No. When the particle kinetic energy no change, the temperature will be no change. So I really, really hope you all can imagine, you all can understand why the temperature do not change during the melting and during the boiling process. Let me know in the chat box. Are you okay with this? Okay, so guys, now we are done with this. Okay. Okay, let's do some exercise together. Yeah, we're done. Huh? We are all done with heating curve. Huh? Finish already. I already finished what I need to teach you today. All done. So now, for the next 10 to 20 minutes, let us do some exercise together. Yeah, for the next 10 to 20 minutes, let us do some exercise together. Yeah, to check whether you really get the idea or not. Yeah. Okay, let's do some subjective. Let's do some subjective question. Okay. So this question is a continuation from just now. Just now we already completed here. So here there's another one more. Okay. The experiment result had been recorded and the diagram show the graph of temperature against the time. So obviously this is a heating curve lah. This is a heating curve. So explain why there is no change from point B to C. So why? So they always love to ask this question. Why temperature is constant? Why temperature didn't change during the horizontal line? They love it. They seldom ask what is happening here, what is happening here. They always ask here. They always ask us to explain why temperature didn't change at here. So do we know what process is happening? Yeah, this process is melting. Huh? So we know that this is melting. So why during melting temperature didn't change? Why the temperature didn't change at all during the melting process? So remember, imagine melting, you want to change solid to liquid. So when you do melting, what happened? All the heat, they didn't enter the particle. All the heat used to cut. So you use the heat to cut something. So no heat can go inside the particle. Okay? So that's why the temperature didn't change. Because if you want temperature to change, the heat must go inside so that you get more kinetic energy. But now all the heat, they used to cut already. So you cannot use the word cut lah. So what is the proper word to be used? What is the proper word to be used? Okay, all the heat absorbed. all the heat absorbed. All the heat that you absorb, you already use the heat to do what? To overcome. You use the heat to overcome. Overcome means cut. What you want to cut? Force of attraction. You use all the heat to overcome the force of attraction. So where is the force of attraction? So now the force is between what? The solid, right? All the solid sticking together, you want to cut the sticking solid. So all the force of attraction between solid particle. That's it. So this is a very common, very popular question in the exam, which I hope you all can understand how it works. Okay, so you get this. Yeah, you get a mark. Sometimes they are stingy. They give 1 mark. Sometimes they give 2 mark. So no matter they give you 1 or 2 mark, the answer is the same. You write the same answer. Not it doesn't matter they give you 1 or 2 mark. Yeah, it doesn't matter they award you all with 1 or 2 marks. Yeah, you write the same answer. Yeah, that's all. Okay, next one. This is a question coming from Pahang, 2023. So this is the diagram for heating curve. And this is the heating curve graph. What is the particle in naphthalene? Same thing. Naphthalene is C10H8. So naphthalene is made from carbon, which is non-metal. Naphthalene is made from hydrogen, which is non-metal. Non-metal and non-metal join together, you get molecule. Right? You get molecule, yeah? Right? Non-metal and non-metal, they join together, you get molecule. Remember, a particle you have atom, you have molecule, and you have ion. Huh? Make sure you know the difference. Okay, see? Why the temperature is constant? Constant means no change from T1 to T2. So T1 to T2, it's here. Can you see that? They love the question, right? They love it. They always love to ask why the temperature didn't change. Okay, so what is this process? So this process, you heat a solid, it's melting. So why melting temperature didn't change? So the answer is exactly same as just now. Okay? When you do melting, all the heat going in, you go to cut the solid. When you use the heat to cut the solid, no heat can enter the particle. So the particle don't get extra energy, so the temperature didn't change. So copy the same thing. Do you realize that for the same answer, just now the question so stingy, they give you 1 mark, but now for the same answer, now they award you with 2 mark. Understand? So so no matter they give you 1 or 2 mark, the answer that you write is the same. Yeah. Next one. During the heating of naphthalene, why naphthalene is not heated using Bunsen burner? This is one extra knowledge. Okay. Why we cannot heat naphthalene directly? Why we don't do direct heating using naphthalene? So this is one extra knowledge for your information. Naphthalene, okay? Naphthalene is a very flammable substance. It will catch fire. So if you do direct heating, you direct heat the naphthalene, it will catch fire, which is very dangerous. That's why we don't do it. We do indirect heating. You will heat the water, then use the water bath to heat the naphthalene. Okay? Because when you do indirect heating, the heating is slow and steady, so it's safer. If you directly heat naphthalene, it will be a problem because naphthalene is flammable. It will catch fire very, very easily. Okay? Next one. This question came out in MRSM. This is a MRSM trial exam paper. Yeah? So they say, this is a heating curve for solid substance Z. So even they didn't tell you, should know this is melting. Am I right? You started with a solid, you hit the solid, it has to be melting. What is the meaning for melting point? Same thing. What is melting point? So copy back the same answer. Melting point is a constant temperature when a solid change to a liquid at a specific pressure. Okay, that's all. What is the melting point for the substance Z? Substance Z. What is the melting point? So everyone, how to do it? So melting always happen on horizontal line. So they want melting point. Melting point is the temperature. What is the temperature that you melt? So melting, go here. What's the temperature? 78. So if you all write 78, you will get 0. Okay? Why? Because you didn't put unit. If you only put 78, they don't know what is it. Just like, for example, if I ask, what is the mass of that fella? 40. 40 what? 40 gram. 40 kilogram. 40 tons. I don't know, right? So you need to mention, your answer need to be very accurate. So when you have any units, you have to put it. So melting point, it is 78, but degree Celsius. Yeah? Don't forget to put the unit, yeah? Next one. Can you draw the picture for the substance Z from point A to point B? So point A to point B, what we have? So we know that this is melting. Point A to point B, it's here. It's before melting. So before melting, what we have? Solid, right? Before melting, everything's supposed to be in a solid form, isn't it? So can we draw solid? So I do mention last week, right? How to draw solid. So solid, you must draw minimum 3 times 3. So minimum 3 row, 3 column. Minimum. More than 3 and 3 is okay, but minimum. And remember the solid must what? Full box. The box must be fully occupied. Okay? The box must be fully occupied. So the solid might look like this. Yeah? So this is roughly how a solid might looks like. Yeah? That's it. Okay? So I hope everyone okay with it. Okay? All right. So now the temperature from B to C is constant. Why? So temperature B to C is here. So why during melting? Why during melting the temperature didn't change? So same thing, no? Why melting the temperature didn't change? Because melting, you absorb all the heat. The heat used to cut the solid. When you use all the heat to cut something, no heat can go into the particle. So the particle don't get extra energy. When the energy didn't change, temperature didn't change. Yeah, that's it. So can you see how popular it is? This question already appeared 3 times now. Hold on. This question already appeared 3 times already. So if you don't know how to answer, it's wasted. It's totally wasted because you can see yourself how common, how popular this question. Yeah? Right, next one. This question came out in Negeri Sembilan. Negeri Sembilan 2023 trial exam paper. Diagram 6.1 show a graph of temperature against time for naphthalene. Okay, in SPM, they always hit naphthalene. They don't hit other substance. Why? I don't know why. Yeah, they didn't hit other thing. They always hit naphthalene. Yeah, all right. So this is heating curve, staircase going up, only one staircase. Yeah, so that's it. All right. So what is the particle for naphthalene? So quite easy lah. You all should know. Naphthalene is C10H8. Carbon is a non-metal. Hydrogen is a non-metal. Non-metal and non-metal. You are molecule. Yeah. What is the melting point for naphthalene? So melting happen on horizontal line. At this horizontal line, what is the correspond temperature? What is the related temperature? 80. Don't forget to put in the proper unit. Don't forget to put in the unit. So it's supposed to be 80 degrees Celsius. If you forgot to put the unit, no mark at all. Some student will say, sir, if I forgot to put the unit, how many mark they will cut? They won't cut your mark. They will give you 0. No mark at all. They won't deduct your mark if you don't put unit. No mark at all. Next one. Why there is no increase in temperature from P to Q? So P to Q, where are you? P to Q is here. So no increase in temperature means constant. So temperature is constant. Again, why temperature didn't change? Same answer. All the heat absorbed is used to cut the force of attraction. Now, all the heat absorbed is used to overcome the force of attraction between solid particle. Guys, can you see? We discussed 4 questions. All the 4 questions got asked why the temperature didn't change. Can you see how popular it is? Can you see how popular, how frequent they ask the question. That's why you really need to know how to explain. Okay, done. Okay, last thing for today. This is the last question for today. Give me 2 minutes and we are all done. Okay, so the last question for today. Diagram 6.3 show the apparatus. Diagram 6.3 show the apparatus setup for the heating curve, for the melting point for naphthalene. So you can see this is the indirect heating. Naphthalene is here. They put a liquid. They heat the liquid eventually heat the substance. All right. Okay, this is a fantastic question. This question is good. It's not hard, but it's good. Okay. So they tell you you have two substance, X and Y. Okay. These two substance, they tell you the boiling point, 78.5 and 100. They ask you, based on this table 3, which substance is suitable to put in this beaker? So now you are not using the water bath. So you have two liquid here. Which liquid you should put in as the bath? Why? Okay. Which liquid you should put in as the bath? And give one reason. Okay, 2 marks. Okay. So how you know what liquid you should put? Okay, this fella is naphthalene. Naphthalene, previous question, if you look at it, what is the melting point? 80. So the melting point is 80. So which means that if you want to melt the substance, you need to heat until 80 degrees Celsius, right? So do you think we will use substance X? No. Substance X, the boiling point is 78.5. So before I even reach 80 degrees Celsius that I wanted, all the liquid here already boil, they become gas and they dry up. You don't want that, right? You don't want the bath to dry before you heat to the temperature you wanted. So don't want. True or not? So you need to use substance Y. Why? Substance Y is 100. So you heat until 80, substance Y is okay. Substance Y, they didn't boil yet. So when they didn't boil, they won't become gas. They won't escape to the surrounding and the liquid, they won't dry up. Understand? So make sure you all know the liquid that you use as the bath, the boiling point of the liquid must be higher than the melting point of the substance that you want to reach. Understand? That's it. So how to put this thing in words to score a beautiful 2 mark? So which substance is suitable to be placed in the beaker? My answer is substance Y is more suitable. Yeah? So why? Why substance Y is more suitable? Because the boiling point of substance Y is higher than the melting point of the naphthalene that we want to heat. Okay, make sense, ma? Okay, so that I can make sure that this liquid will not boil before I melt my naphthalene. So 2 marks. So I really, really hope you all understand how to do this. I really hope you all understand that 1 and 2, 2 marks here. Okay, so that's it. So that is everything that we need to know for today. Okay, so today, 1 minute summary, what we do? Heating curve, yeah? So today we learned about heating curve, okay? Heating curve, staircase going up, yeah? So make sure you know maximum 2 staircases. The first staircase melting, second staircase boiling. So how to know where is solid, where is liquid, where is gas, where is solid plus liquid, where is liquid plus gas? When you are on horizontal line, change of state is ongoing. When change of state is ongoing, you have 2 states mixing together. Yeah. So after that, you must be able to explain why temperature is constant, why temperature didn't change during the melting process, during the boiling process. This is a super popular question in the SPM. Okay. So guys, let me know in the chat box how's everything? Any feedback for your Form 4 Chapter 2 lesson number 2? This is your second lesson with me. How's everything so far? How's everything so far? So today we are learning something more interesting, right or not? Because last week honeymoon, right? Last week honeymoon, because last week most of the concept you learned before, right? You heard about elements, you heard about compound, you heard about atoms. So those things you heard before, but this week different, right? Today lesson is different because we are learning something totally new. So I really hope you all can understand. Yeah. So again, everyone, if you need help, if there is anything you're not sure, please ask. Don't be shy. Don't be shy, because my experience is that many students, they are so shy and they learn nothing. Seriously, you being shy, you might learn nothing. So I know what you might think. You might think, oh, when I ask the question, how people will judge at me. Guys, don't care so much how people look upon you, please. Don't care so much how people look at you. Don't bother lah. Don't bother. Okay. All right. So you don't be so scared. Oh, when I ask the question, would it be like the question I ask is too easy? Other people will laugh at me. No. Okay. Number one, no people will laugh at you. Number two, even if they want to laugh at you, just let them laugh lah. It's okay. What they laugh is their thing. Okay. Don't care. Don't care so much. As long as you learn something. If you're so scared other people laugh at you and you're not asking at all, you might miss the opportunity to learn something. Seriously. Yeah. So sometimes don't let the ego to be too big lah. Sometimes I know, because sometimes students feel I'm so shy, I'm so shy, I'm so shy, I'm so shy. Okay. For me, the process of learning something, uh, nothing to be shy of lah, nothing to be embarrassed. Okay. And don't feel bad when you're asking a very easy question. It's okay one. Okay. Whatever question you ask, let it be a simple question or a hard question. I will try my level best to help you. That is my promise. Yeah. Okay, so guys, I think that's all. I think we are all done for today's lesson. Thank you so much to stay until the end of the class. Okay, and I'll see you guys again in the next lesson. Goodbye, everyone, and good night. Yeah.